So tonight we're looking at Venus. Venus is right now getting closer and closer to the Sun, and because Venus orbits inside the Earth's orbit, we only see part of the planet's face lit up when it's getting closer to the Sun. We'll never see a full Venus because it's never on the other side of us, and so we never see all of Venus lit up at one time. But what's special about Venus, and what you can probably see right here, is that a lot more of Venus gets lit up by the Sun than, say, the Moon. You never see a crescent moon that is this crescent-shaped. The Moon, basically what's lit up is what you see, but the Moon doesn't have an atmosphere and Venus does. And because, I think that's a woodcock that we hear dive bombing us. I'm here in rural Michigan, physically distancing from just about everybody except from the critters. But because Venus has such a thick atmosphere that carries the light of the Sun a lot further than a rock ball like the Moon that only reflects and doesn't transmit any light along the edge, Venus can get to be a ridiculously thin crescent. There are speculations that it's possible that Babylonians actually were able to make out the shape of Venus as a crescent, and the goddess Ishtar, who is symbolized by horns, was a representation of Venus. That seems to be not really believed widely anymore, but it's easy to see why people who see Venus for the first time in a super thin crescent phase like this would think, well, that's such a large shape in the sky, it's so easy to see this shape with binoculars or with a small telescope. It's really easy to imagine somebody having good enough eyesight to be able to actually resolve that as a shape in the sky. Usually, the brightness of Venus, when you just look at it, kind of prevents that. I can't see any shape there at all. The only planet that I can see as a shape is Jupiter, and Jupiter is ridiculously large in the sky compared to everything else, because Jupiter is ridiculously large compared to everything else. But, so I only see Venus as a very, very, very bright spot. If Venus were a little dimmer, ironically, it might be possible for us to see the shape. It's just under the limit, the theoretical limit of what the human eye can resolve. And there are astronomers like Stephen J. O'Meara who can see substantially more details than theoretically the eye should be able to resolve. So, it's not too bad. It's really close. You could almost imagine somebody with spectacular eyesight being able to do it. But because Venus is so bright, even in the daytime sky, there seems to be too much contrast for people to see that kind of detail. But I would be happy to be wrong. Venus is one of the very small number of planets that we can see any details on with amateur equipment, unless you're Stephen J. O'Meara. On Mercury, we can see Mercury's phase, but because Mercury doesn't have much of an atmosphere, it's like the Moon. We only see the part that the Sun is actually bouncing off of directly. And because it's so close to the Sun and never gets very far away from the Sun, it's always in the twilight glow, and it's really hard to pick up unless you're really, really trying to see it. There's a story, which may or may not be true, that Nicholas Copernicus never actually saw Mercury in his whole life because it was just such a difficult thing to see. Wow, these woodcocks are really something. What they do is they fly very high up into the air, I think maybe even a mile high, and then they come down like a rocket falling, and their tail feathers actually make this really strange sound. So if I sound distracted, it's because I hear them going off in my ear. You probably hear them in the background too. But of course, Earth we see in exquisite detail. The moon we see in exquisite detail, but it's not a planet. Mars we see for about 6 months out of every 3 years in very good detail if it isn't having a dust storm, but most of the time, for whatever reason, when Mars gets close to us, it also starts having a dust storm, possibly because the good oppositions are when it's closer to the sun, is my understanding, and when it's closer to the sun, that tends to kickstart the dust storms. Don't quote me on that, but I believe that's true. I have only a couple times in my life really seen Mars in truly spectacular detail. Usually you see the dark shapes of the Syrtis Major and the major dark features on the surface, but in terms of actually seeing the mountains, in terms of seeing the canyons, I've only been able to see those under really exceptional circumstances. Of course, Jupiter is always good. Jupiter is just incredible to look at. There's all sorts of details on the face of it, not just the great red spot, but the bands and the sub-bands and the sub-sub-bands and the little spots that, if your telescope is well collimated, or at least better than this one is, you can see visually, and you can definitely see in astrophotos. So you can, if you're not used to looking through a telescope, you can see I'm taking it out of focus, and now we're seeing lots of Venuses. See how it's like a puddle of Venuses? And as we start focusing it in, all those individual images start combining into a single image. And then when we go past in the other direction, you see they start falling apart into a bunch of little Venuses again. So if you're in perfect collimation, you should be able to get it down to a perfect alignment where all of the different parts of the image, all of the light from everywhere on the mirror comes together in one place. But it's hard I'm using the iPhone built-in video app, and that's not very good at doing this, I have to say. I use a different app, Halide, to take photos, and that allows me to take some really spectacular astrophotos with just an iPhone. But apparently it doesn't do video. I tried to get it to work and I couldn't make it work. So this is the best I can do. I apologize. Jupiter also has its moons that you can see dancing around, forming different patterns around it, casting shadows on it, going behind it, just all kinds of stuff that you can see in the Jupiter system that is super cool. And of course, Saturn, it goes without saying, is a constantly evolving, wonderful thing to see. Because Earth's orbit and Saturn's orbit are slightly tilted, we actually see the rings over a 26-year cycle, I believe, as it goes around the sun. We actually see the rings splay out wide one way, then tilt towards us, and then disappear when we cross the plane of its orbit. The rings are just a flat line, and we basically stop seeing the rings. And that's a really good time to look for Saturn's moons, because the moons aren't being blocked or distracted from by the rings anymore. And then we actually go below the rings and we see the South Pole, and then the whole cycle repeats again. I think that's a 26 years cycle. I think that's right, but again, look it up yourself. This is not, I'm not your Wikipedia. But Saturn's moons are not quite as entertaining as Jupiter's moons. We never see Saturn's moons cast shadows on the face of Saturn, partly because Saturn is further away, partly because Saturn's moons are smaller than Jupiter's moons, and yeah, maybe it has something to do, maybe we can see shadow transits, but only when the rings are a flat line. That could be the case. That's something to look up. It's left as an exercise to the viewer. And then Uranus and Neptune, maybe if you're using tremendously large amateur telescopes, which I don't really think qualify as amateur anymore, maybe you can see some details on Uranus. I don't think you can. I think maybe Stephen James O'Meara saw some detail on Neptune, if I recall correctly, but don't try this at home, kids. They're easy to find comparatively. They're easy to see because their orbits take so long. They don't really go anywhere, so when you learn where they are, it's really easy to get back to them. If you are in skies dark enough that you can see the stars in Hydra or Capricornus or wherever they're hanging out these days. If you can see the bright stars there, it's pretty easy to get to those planets. But other than the color, it's hard to see, and unless you have a really big telescope, it's even kind of hard to see the color, I find. I frequently end up confusing myself between Neptune and various blue stars and stars that aren't quite, that seem dim. And then there's Pluto. I've only seen Pluto once in my life, and I will never see it again, I'm pretty confident, because the one time I saw it, it was passing over a dark nebula near the center of the Milky Way, and that dark nebula was actually so close to us and had so few stars in front of it that I literally was able to count the stars that should be there and figure out which of the stars in front of this dark nebula was Pluto. And that is an opportunity that isn't really going to come around again. So you would be much better off looking at one of the other should-be planets, like Ceres in the asteroid belt. Ceres or Vesta. There's a lot of really great asteroids that are much easier to see than Pluto, and because those asteroids move comparatively fast to Pluto, you can actually confirm that you saw them in the course of a night, which is not really true. To see Pluto move over the course of the night, you basically have to memorize a star field and then have clear skies the next night, and then look the next night at the same spot and remember what stars you saw in the field and see which one you moved. Or you take a picture and then you're not really seeing it visually. So yeah, seeing Pluto, overrated. I'm still glad I did it, just so I can say I did it. But I'm not exactly lining up to try visually spotting Makemake or Eris or Sedna or any of the other distant dwarf planets. Venus is a very special planet to me. It occupies such a huge role in human history and in the history of science in determining how far the Earth was from the sun and basically what the scale of our solar system was through the transits of Venus when Venus passes in front of the sun, that it's always really great to watch Venus go through its cycles. And it's always sad when it kind of gets to this point where it's going down this, or after it's been up for a substantial portion of the night, now it's starting to go down much earlier in the night as it starts getting close to the sun again. As it gets close to the sun, it's not going to pass in front of the sun from our perspective. It's going to go just below the sun. And then we won't, basically, we will keep seeing it for about another month, I think, pretty easily. After that, it's a little too close to the sun to safely see, unless you're an experienced observer and know how to prevent getting the sun in your optics or in your eyes. And then in a matter of months, I think about 4 or 5 months, we'll see it pop out on the other side of the sun, and it'll become a morning object again. Venus is such a bright object compared to most other stuff in the sky that people frequently report it as a UFO. And you know, I have to say, it's kind of understandable why people report it as a UFO. It's so bright compared to any star, and it just kind of sits there, and it looks, the quality of the light coming from Venus is very different from the quality of light coming from basically anything else in the sky. The moon is really the only comparison. Jupiter is similarly blindingly bright, but because we're inside Jupiter's orbit, we see it as a circle, and so it looks a lot more uniform, it looks a lot less spiky. But when Venus is a thin phase like this, even to the naked eye, it looks very spiky and weird. So it's, you know, I can't really fault people for being confused. But I do encourage you, if you see a UFO, get out your binoculars and find out what it is. I mean, it's only unidentified until you identify it, and it's always worth identifying it. There's an amateur astronomer in Michigan who has had the good or bad fortune, I don't know if he has crazy neighbors or what, but to frequently observe weather balloons bursting at high altitudes while he's doing observing. So he has some pretty spectacular videos of these weather balloons bursting at high altitudes. And that is a weird thing to see. That's a real UFO until you figure out that it's a weather balloon. So, well, I hope you've enjoyed this little taste of Venus observing. And the real way to do Venus observing is just keep looking at it night after night as it becomes a thinner and thinner crescent. And as long as it's safely away from the sun, as long as you can see it as a bright star in the sky after the sun is safely past the horizon, you should take out your binoculars and look at it, because it is really a beautiful thing to see. And you will be amazed as it gets thinner and thinner at how ethereal and how strange it looks. So keep looking up, and we'll see you next time.